Every day, millions of people across the country perform the exact same kitchen ritual. We grab leftovers from the fridge, place them in a convenient plastic container, put it inside the microwave, and press start for 3 minutes. We don't think twice about it. When the timer beeps, the food looks completely normal, hot, steaming, and ready to eat. But beneath that steaming surface, a hidden process has already begun. According to a landmark 2023 laboratory study, those brief 3 minutes in the microwave can release millions of microplastic particles into your food, and it gets even smaller. The same process can shed billions of nanoplastic particles, debris so tiny that it is completely invisible to the naked eye. There are no obvious chunks floating in your soup, yet its molecular reality is vastly different. This discovery does not mean we need to fear the microwave oven itself. Your microwave is not making your lunch radioactive or poisonous. The real issue is much more ordinary. It is the container we choose to use. The fundamental question we need to ask is not about electromagnetic waves. The real question is, what actually happens at a physical level when high heat, liquid food, and synthetic plastic meet inside that box? Plastic food containers have become completely unavoidable in modern American life. They are in our office break rooms, our kids' school lunches, and our meal prep containers stacked in the fridge. We buy takeout boxes, prepackaged frozen dinners, baby food pouches, and use plastic cling wrap daily. Because these products are incredibly lightweight, cheap, and durable, they have quietly become the default storage medium for almost everything we eat and drink. Most of these containers carry a familiar label stamped on the bottom: microwave safe. Because of the stamp, we naturally assume the container is completely harmless under high heat. In our minds, microwave safe means safe from chemical leaching, safe from physical degradation, and safe for our health. We think that if the plastic container doesn't melt, warp, or catch fire when heated, then everything must be perfectly fine. But that assumption might be a dangerous misunderstanding. This is where the scientific puzzle begins. Researchers are asking a much more precise question than whether a container will survive the oven. They want to know, even if the plastic container remains visually intact, does it still shed microscopic debris into the liquid touching it? Just because a plastic bowl doesn't melt into a puddle of goo doesn't mean it isn't shedding millions of tiny polymer structures directly into your hot soup. To find answers, researchers from the University of Nebraska-Lincoln conducted a controlled study in 2023, which was published in the peer-reviewed journal Environmental Science and Technology. They focused on plastic containers commonly found in American households, specifically looking at polypropylene containers and reusable polyethylene food pouches. These materials are heavily used for baby food and general meal storage, making the results highly relevant to the everyday habits of families across the nation. Instead of testing with complex home-cooked meals, which vary too much to measure accurately, the scientists used precise food simulators. They filled the plastic containers with deionized water and a 3% acetic acid solution. This mildly acidic liquid was specifically designed to mimic the properties of acidic foods we eat daily, such as tomato sauce, citrus fruits, and certain vegetables. This standardized setup allowed the researchers to measure the plastic release under clean, repeatable conditions. The researchers then subjected these filled containers to several common real-life storage scenarios. They simulated storing food at room temperature in a pantry, keeping it cool inside a household refrigerator, leaving it in a hot car or warm room, and finally heating it in a standard microwave. The microwave test was simple and straightforward: 3 minutes of heating on high power. This allowed them to compare the passive release of particles against the impact of active heating. When the results came in, the numbers were staggering. Under the heated microwave conditions, certain plastic containers released up to 4.22 million microplastic particles per square centimeter. Even more shocking was the nanoplastic count, which reached up to 2.11 billion particles per square centimeter of plastic surface area. Heating triggers a massive release of synthetic particles. We must look closely at that specific unit, per square centimeter. This distinction is crucial because it means the total number of particles you might consume scales with the size of the container and how much liquid is touching the plastic walls. A large container holding a full bowl of soup has a massive surface area, meaning the total count of micro and nanoplastics released into a single meal could be far higher than the numbers reported per single centimeter. To understand why this is concerning, we have to look at the differences in scale. Microplastics are defined as plastic particles smaller than 5 millimeters, roughly the size of a sesame seed, down to a microscopic speck. While they are incredibly small, many microplastics can still be identified and measured under a standard laboratory microscope. But they are only the tip of the iceberg, because the vast majority of the particles released are even smaller. Nanoplastics represent a completely different realm of tiny. They are defined as particles smaller than 1 micrometer, which is far smaller than the width of a single human hair or even a red blood cell. Because they are so incredibly microscopic, nanoplastics are exceptionally difficult to detect, track, and measure. They don't behave like normal dust. They are so small that they can remain suspended in liquids and easily bypass standard physical barriers. This extreme difference in size is exactly why scientists are deeply concerned. While larger microplastics might pass through our digestive systems relatively unhindered, nanoplastics are small enough to cross biological membranes. They can potentially interact directly with cells, enter the bloodstream, and travel to organs throughout the body. The smaller a particle becomes, the easier it is for it to slip past the natural defense mechanisms that protect our tissues from foreign objects. To understand why heating causes this massive shedding, we have to look at how a microwave works. The appliance uses non-ionizing electromagnetic radiation, which specifically target and agitate polar molecules, like water, inside your food. This rapid vibration creates friction, generating heat directly within the meal. The microwave radiation does not alter the food's atomic structure, nor does it make the food radioactive. The microwave itself is safe. The real catalyst for plastic breakdown is simply the rapid rise in temperature. At a microscopic level, plastic is not a perfectly smooth, solid barrier. It is made of long, repeating chains of molecules called polymers. Over time, through normal use, washing, and utensil scrapes, the plastic surface develops microscopic cracks, scratches, and structural weak points. When you apply high heat, these polymer chains begin to vibrate rapidly and expand. The liquid and heat stress these pre-existing structural defects, causing the fragile surface layers to break apart and shed fragments directly into the food. This thermal breakdown leads to two separate issues inside your microwave. First, it physically sheds millions of microplastic and nanoplastic fragments. Second, the heat accelerates chemical migration, allowing synthetic additives, which are used to make the plastic flexible, clear, or heat-resistant, to leach into your food. This combined release is why heating food in plastic is fundamentally different from storing cold food in plastic. High heat, steam, and liquid create a worst-case scenario for polymer stability. This brings us back to the great illusion of the microwave safe label. When a manufacturer brands a plastic container as microwave safe, they are generally certifying that the container will not melt, deform, or structurally fail in a standard microwave. It is a measure of the container's survival, not your food's purity. it does not mean the container has been certified to release 0 microplastics, 0 nanoplastics, or 0 chemical additives into your dinner. The label is about convenience, not complete chemical safety. Because regulatory standards do not currently limit the release of microplastics from consumer products, the responsibility falls on us. This regulatory gap is why an increasing number of toxicologists and pediatricians suggest a simple precautionary approach. We should avoid heating food in plastic altogether. We do not need to wait for perfect regulations to protect ourselves when we can easily choose safer materials that have been trusted for thousands of years. To understand the potential biological impact, the Nebraska researchers took their study a step further. They exposed cultured human embryonic kidney cells to the plastic particles harvested from the heated containers. After 48 hours of exposure to a concentrated solution of these micro and nanoplastics, approximately 75% of the kidney cells died. This lab result is striking, but we need proper context. A cell culture study in a plastic petri dish is not a direct representation of what happens inside a living human body. Cells in a dish are directly exposed to high concentrations without the protective barriers of the digestive tract, liver metabolism, or the immune system. We cannot assume that eating a microwaved meal will instantly kill your cells. However, these laboratory results act as an early warning sign, proving that these microscopic particles are not biologically inert. The most honest scientific conclusion is not to panic. Eating one meal warmed in plastic is not a sudden medical emergency. The science on long-term human health effects is still actively developing, and we do not have definitive answers yet. However, because the laboratory findings show high rates of particle release and potential cellular toxicity, minimizing our daily avoidable exposure is simply a common-sense decision that carries zero risk and immense potential benefit. We must clearly separate the cooking technology from the container. The microwave oven is one of the most efficient, safe, and convenient kitchen appliances ever invented. It does not ruin your food. The only variable that introduces risk is the plastic container. By simply changing the vessel we place inside the microwave, we can completely eliminate the problem. We can keep the modern convenience of quick heating while completely removing the unwanted side effect of microplastics. The easiest and most effective swap you can make is transferring your food to glass or ceramic plates and bowls before reheating. It takes only a few extra seconds to scoop last night's leftovers onto a ceramic plate or into a glass bowl. These inert materials do not degrade, melt, or shed synthetic polymers when exposed to heat and moisture. This single, simple adjustment eliminates millions of microscopic plastic particles from entering your daily diet. We also need to be careful with other common kitchen plastics. Avoid letting plastic cling wrap touch hot food in the microwave, as the rising steam can melt the thin film directly onto your meal. Instead, cover your food with a simple paper towel or a reusable glass lid. Additionally, never reuse single-use plastic takeout containers for reheating. These thin plastics are designed solely for transport and break down even faster under thermal stress. Finally, don't fall into the BPA-Free marketing trap. Many consumers buy containers labeled BPA-Free, believing they are completely safe. However, BPA is merely one specific chemical additive. Replacing BPA with similar compounds does not stop the physical plastic container from shedding millions of microplastics and nanoplastics when heated. A BPA-free plastic container is still made of synthetic polymers, and it will still degrade under high heat. The safest choice is always glass or ceramic. While a single microwaved meal in a plastic tub won't harm you, our habits are measured over years. Hundreds of quick lunches and thousands of reheated leftovers add up to massive cumulative exposure. Making the effortless switch to heating in glass completely removes this unnecessary risk from your life. Do you still microwave plastic? Share your thoughts below. To learn more about microplastics, watch our next video on plastic cutting boards.